Good evening to everyone. Give me a confirmation if you guys can hear me. Good evening, everyone. Give me a confirmation if you guys can hear me. Yes or no. Good evening. Can you guys hear me? I think there's some delay in the response. Just give me a second. Chat reply. Okay. Awesome. So I hope my voice is audible to you, right? Is it good? Is it good? Yes or no? Perfect. Okay. So yesterday we have started out with the introduction of machine learning. We have seen how exactly machine learning has made an impact currently, right? What all we have studied, did you guys remember anything? Can you guys give me some quick topics or some quick keywords that we have talked about yesterday? Anyone? What is machine learning, why machine learning, and how exactly it is different from the previous automated part, and what are the different types of machine learning we have, and what are the things that we should know before starting with the machine learning. Okay, now here I'm having a quiz for you. You need to tell me what was the first step to start with machine learning. If you want to start with machine learning, I have told you different procedures, right? First you have to learn different topics and concept. What was the first concept that we have discussed that you should at least know to start with machine learning? Come on, let's see who will going to give the right answer for this. What was the first step that we have discussed yesterday to start with machine learning? Anyone? Come on. Come on, guys, tell me what was the first step that we have discussed yesterday which is necessary to start with machine learning. Exactly, it's the programming language, right? The first step is the programming language. And which programming language we have discussed about? It was the Python programming language, right? So at least you should have a knowledge of programming language, not only in the field of machine learning but in the field of computer science. If you want to do anything related with the computer science field, either it could be making a software, making a website, making an application, you should at least know a programming language, right? After that, we have discussed that you should have a knowledge of how exactly a database works, right? Then jumping from there, you should know data analysis, right? And after that, you should know about the statistics. And statistic is the heart of machine learning, deep learning, or any other form of data science domain. Okay, so statistic is must. Okay, if you don't know programming language, learning a programming language is very easy. See, for machine learning you don't need to have an advanced level of programming language. If you are starting with Python, right, we don't expect you to have an advanced knowledge of Python. You don't need to learn about multiprocessing, how to go with Python with multi tasking, how to integrate it with different other parts, and so on and so forth, right? With a basic of different programming language, you can start with machine learning, so that's not a difficult issue, right? But the thing is that you should at least know and have the exposure of statistics. If I ask you what is mean, you should know what is mean, you should know what is mode, you should know what is median, right? You should know what is regression, what is correlation. Like during our school times, we have learned a different equations, right? Y equals to mx plus c, a square plus b square, something, so on and so forth, right? So during that time, it was sounding like senseless. We were like that, where are we going to use all these equations, right? Yes or no? If we were used to happen that when we are doing the trigonometry, right, we have tan theta, sine theta, cos theta, and we were like imagining that where the hell in the life we are going to use these topics, right? We are not going to use tan theta, we don't, and so far also we haven't used that, right? But in machine learning, in deep learning, we use all this concept. This is the place where we are going to utilize it. So you can say that most of the statistics that are required for machine learning and deep learning you have already studied during your 12th. Okay, that knowledge needs to be brushed up. You should know about the correlation, you should know about the inferential statistics and the descriptive statistics. You should know about the hypothesis testing. Hypothesis testing plays a very vital role in the field of machine learning to make a decision, what decision exactly you want a machine to make. Okay, so after jumping from statistics, we are here on the machine learning. And can you tell me how many types of machine learning are there? What are the different types of machine learning, or different segment or different categories in which machine learning has been divided? Anyone? Anyone? Come on. What are the basic types in which machine learning is being classified? Come on. Very general, very basic. Come on, come on, come on. How many types are there? We have learned about the supervised learning, we have talked about the unsupervised learning, and we have talked about the reinforcement learning, right? And furthermore, you have different other types. Some has semi-supervised and so on and so forth, but they are being created with the help of these three types only, right? So the basics are supervised, unsupervised, and your reinforcement learning. Okay, let's write this over here. Let's go on to the previous slide. So types of machine learning was a supervised learning, your unsupervised learning, and your reinforcement learning. The thing is that which learning we have to go with will be decided by looking at the data. Okay, by looking at the data, we'll get to know whether we have to go with the supervised learning or unsupervised learning, right? If your data has the outcome or the target variable, then you have to go with the supervised learning. If your data doesn't have the target variable, then you have to go with your unsupervised learning, right? And in the supervised learning, it has also been divided into two parts, that is your regression and another being the classification. Okay, now if your target values, okay, if a target variable contains the value that are continuous, okay, what are the continuous? Anyone know about the continuous value? What is the continuous value? Anyone? Do anyone know about what is a continuous value and discrete value? Anyone? No? Okay. So the continuous value are the decimal values, such as if you have these kind of part like 23.45, you have 26.98, you have 90.0, like this. These are the continuous value, right? And when we talk about the discrete values, these are 1, 2, 3, 4, 5, 6, and so on and so forth without the decimal value. Okay. Now, if your data point contain any of these, but it should not form a categorization. It should not form a categorization. In the target value, you cannot have a category. If you are having a category in the target value, then you need to go with the classification. If you don't have any categorization in the target value, then you need to go with the regression. Okay. And in this regression, we have different models. Okay. And different algo, among which one is your linear regression. Okay, so in this session today we are going to talk about the theoretical concept of linear regression and how exactly, what exactly is the behind scene, what is the behind scene of this linear regression, right? So the thing is that if you want to perform linear regression, it's just a 5-minute task on your, like the coding part is just a 5-minute task. The reason being is that currently we have a library that supports everything that has been written for you. All the boilerplate has been created for you. So what you need to do is you need to go on and just you have to use a command and simply it will going to be done. But for that we have to know what is a backend story, what exactly happens in the backend, right? So today we are going to start with linear regression algorithm. Okay, are you guys ready for this? Are you guys ready for this? Yes or no? Come on. Are you guys ready for this? Yes or no? Okay, perfect. Now there are two things that you need to remember about the linear regression. One is your linear part and another is your regression. This is also known as a predictive analysis. This is also known as a predictive analysis. Let me write it this over here. Predictive analysis. That means you are going to predict something, right? Now you are going to predict something from the data. Now you are going to tell about the future, what might gonna happen in future. Okay, now the thing is that how exactly this linear regression work. Before that, let me show you how exactly a data looks. Okay, so let me copy this image from here and paste this over here. Okay, so this is our data. Okay, now let's see some of the specification about this data. The data is in a form of a table, right? This is a table, yes or no? This is in a form of a table where we have rows and we have columns, right? We have rows and we have columns. That's the specification about a table, right? And in this table, let's understand what do we mean by the target variable. We are talking about target variable since yesterday, right? If you have a target variable, then you have to go with supervised learning. If you don't have a target variable, then you have to go with your unsupervised learning, right? Now over here, we have two columns, that is your years of experience and salary in dollars. Okay. Now this table or this data suggests that according to a particular year of experience, what exactly is the salary being given to an employee. Okay, so if you are having 2 years of experience, you will be getting $15,000. Okay, if you are having a 3 years of experience, you will be getting $28,000, so on and so forth. Now over here, if you look forward, we have two columns, and this column, this salary column is dependent upon the years of experience column. Yes or no? This salary column is dependent upon the years of experience column. Are you getting this? Yes or no? Are you getting this? Yes or no? Give me a confirmation, please. Are you guys getting this? Yes or no? Okay, perfect. Now if you see, this salary column is absolutely dependent upon this column, because unless and until you know about the experience, you cannot tell about the salary, right? If I don't know about the years of experience, I cannot tell you the salary, because over here the salary is different. All the salary is different and they varies according to the years of experience, right? If you say that my years of experience is 13, right? So for that part, salary might be different, right? So we can say this salary column is dependent upon the years of experience column, right? So that's why it is known as a dependent variable. This is known as a dependent variable, or you can call this as a target variable as well. Target variable, because the target variable is the variable that you have to predict. We have already seen that linear regression is also known as predictive analysis. That means you are going to predict something, right? If you are having this data, so obviously you will going to make a model that can predict the salary if you are having a certain experience. Yes or no? Right? And the second scenario, if you see, years of experience is an independent variable because it is not dependent upon salary. Years of experience doesn't depend upon salary, right? If you say my salary is, let's suppose, $40K. Okay, you say $40K is my salary. This doesn't specify that your years of experience according to the salary will be 2 years, 3 years, 4 years, 5 years. Yes or no? It can also happen if a company is doing good, they can offer this salary to a person who is having only 1 year of experience. So it might happen if they can give it to 2 years of experience guy, right? So over here, years of experience is not dependent upon salary. It doesn't depend upon the variable salary. That's why this variable is known as an independent variable. It is known as independent variable. And as well it is known as feature. It is also called as a feature. Till here is it clear? Yes or no? Till here is it clear? Yes or no? Please give me a confirmation. Is this clear till here? Yes or no? Come on. Okay. Perfect. Okay. So over here, this is a dependent variable or a target variable which we have to predict, right? I want to predict a I want to predict a salary based on the years of experience. So what I'm going to do, I'm going to take this data and I'm going to train a model, and I'm going to say a model that, hey, I'm going to give you years of experience, and according to that you need to tell me the salary, right? So that is known as a target variable. That is known as a target variable. This is a target variable, okay, which is missing when you are working with the unsupervised area. Okay, whenever you are working with unsupervised data, you will always see that this target variable is always missing, right? So looking at to this data, you will going to decide whether it needs to go to the supervised learning or unsupervised learning. Okay, and then after that you will going to decide whether it will going to go with regression or classification. Okay, let's see this over here. If you see, we don't have any category. If you see over here, we don't have any category, right? We have all the values in a numerical form, but it doesn't form any category. That $15,000 is one category or $16,000 is one category. No, right? All the numbers are different and they cannot form a single category. That's why we have to go with regression. Okay, that's why we have to go with regression other than classification. If the target variable contains all the values in a form of you can call this as a category, right, then we have to go with the classification. Okay, let's take one more example. Let's say we are having a column as height, okay, and then we are having a column as weight, okay, and based on this we have one more column as age, and based on all these three factors we are defining a BMI. You know what is BMI? Do you guys know what is a BMI? Yes or no? Do you guys know what is a BMI? Yes or no? Anyone? Let's see. Okay. Okay. So BMI stands for your, come on, let's see who will going to give the answer for this. Anyone? No one? Perfect. It's a body mass index, right? So based on the height, based on the weight, based on the age, you will going to define a body mass index. Now see this. BMI can only be found out when the height, weight and age is known, right? BMI can only be known when you know the height of the student, when you know the weight of the student, and when you know the age of the student, right? If you don't know about height, weight and age, you cannot find the BMI. That means this BMI is a dependent variable. This BMI is a dependent variable because it depends upon height, it depends upon weight, it depends upon age, right? So in this case, BMI becomes the target variable that we need to predict. So based on this data, we are going to create a model, and we are going to say the model that we are going to give you a height, we are going to give you weight, and we are going to give you age, and in return what you need to do is you need to predict what exactly is my BMI. Are you getting this? Right? So in this case, BMI stand as the independent variable, whereas BMI stand as a dependent variable, whereas height, weight and age is absolutely an independent variable. Okay, it is absolutely an independent variable and also called as a feature. Till here is it clear? Yes or no? Okay. Okay. Perfect. So let's move on to understand about linear regression and what exactly is the backend story of linear regression. Okay. So we are going to take this example. Let me copy this data. over here. Okay, now linear regression is of three types. Okay, the first type is your simple linear regression. First type is your simple linear regression. Your second type is your multiple linear regression. And your third type is your polynomial linear regression. Okay, now the difference between these three is that when you are having only one feature, and one target variable, let me write over here, one feature and one target variable, then it is known as a simple linear regression. Okay, this is a target variable. Okay, this is not television. Okay, now when you have multiple feature, or let me write over here, one plus feature, that means more than one feature and one target variable, then you call this as a multiple linear regression. Okay, and we call as a polynomial linear regression when you get when you try to find out your best fit line and it is not linear, then we call this as a polynomial linear regression. Okay, so in this we try to find out a best fit line. Okay, and that best fit line is always linear. Okay, but in some cases when the best fit line is not linear, that is known as a polynomial linear regression. Okay, and the motive of linear regression is to find out the relation between the two entities. The motive of linear regression is to find out the relationship between the two entities. I want to find out that what exactly is the relation between these two entities, years of experience or salary in $1,000, right? So if I want to map this, I can say, let's say I'll map this in a form of a graph. Okay, so let's say we have over here we have X that states the years of experience. Okay, and we have Y that is your years in salary, right? If I make a line like this, let me do this like this, right? What exactly these two mean? It means that as the X will going to increase, automatically Y will going to increase, right? That means as the years of experience of a person will going to increase, automatically the salary will also going to increase. Now there is a relationship between these two entities, that is there's a they both are directly proportional. They both are directly proportional to each other. As the years of experience will going to increase, the salary will also going to increase, right? So the motive of linear regression is to find out the relationship between the two entities. Is this clear to everyone? Yes or no? Is this clear? Is this clear to everyone? Yes or no? Okay, come on, is it clear? Yes or no? Perfect. Now how exactly we calculate the value, how exactly we predict and we calculate the value? Let's suppose if someone asks you that based on this data you need to predict out that if a year of experience of a person is 15, right? If a person is having 15 years of experience, then you need to predict out what will be the salary. This is the question. Okay, this is the question, that is 15 years of experience. If some person is having 15 years of experience, then what will be the salary? Now if you see on this data, you will not going to find out any row where there is mention about the 15 years of experience, right? That means we have to predict it out. We have to predict this out based on this particular data, right? How exactly linear regression will going to do this? Okay, so there is a formula to predict out. So let me say this is your target variable, so we denote the target variable with the letter Y. Let me write this Y because we have to predict Y, right? and the feature is being given by the variable known as x. Okay, so we have to take and perform all the operation on x to find out the y, right? So the formula of linear regression is y equals to beta o x plus beta 1. This is the formula of linear regression, where if you see, this y is your independent variable. Okay, that means that which you have to predict salary, right? And over here x is your years of experience, that is your independent variable. Okay, now we have b naught and b1. They both are the constants. Okay, they both are the constant. Okay, beta o over here, beta o denotes that it's a regression coefficient. If you have learned about the Pearson correlation, if you have ever heard about the Pearson correlation, or you might have heard about the Carl Pearson correlation, right? So there always we used to find a regression coefficient. Did you guys remember that? During our school times we have learned this topic, right? Pearson correlation, Carl Pearson correlation, yes or no? Spearman rank correlation, if you remember, right? So there we always used to find a correlation. They always used to find a correlation, and that is known as a correlation coefficient, right? Or you can call this as a correlation constant. So this beta naught denotes the Pearson correlation coefficient. Okay, and this beta 1 is your regression beta 1 is your intercept. Beta 1 is your intercept, or you can call this as a constant. It says it's the prediction of y when x is 0. It's the prediction of y when the x is 0. Let me write this over here. You can call this as the predicted value of y when x equals to 0. Okay, so let me write this as y when x is equals to 0. That is your beta 1. And this beta naught is your regression coefficient. Okay, so this is the formula that we have for the linear regression, and it is absolutely similar to one formula you might know. The formula says y is equals to mx plus c. Have you ever seen this formula anywhere? Y is equals to mx plus c. Anyone? Y is equals to mx plus c. Come on, anyone? We all must have seen this formula during our school days, or even though if you are if you have came across the engineering mathematics, you might have seen this formula as well, right? Y is equals to mx plus c, where m stands for the slope and c is the constant, right? Similarly, we use this formula where you have to predict out y. You have been given the x, that is your feature value. The beta naught, or over here m, stands for the regression coefficient. That's why I'm telling you that statistics is very, very important. Okay, so statistics is the heart of machine learning, or you can call this as a data science, right? So it's the heart of data science. You should know about statistics when you're dealing with machine learning. It helps you out to improve the machine learning accuracy, works with the hyperparameter tuning, and so on and so forth. Okay, now this is a formula with the help of which we can easily predict out what will going to be the output of this y, right? Now over here we need to find out y and the x. X is given as 15. X over here is been given as 15. That means years of experience is 15. Now you have to tell me what is your y, right? Now based on this data, we calculate the regression coefficient. Okay, so there's a huge formula to calculate a regression coefficient. You should know about that. And after that, let's suppose this is been denoted by r. When you know about this, then you have to perform the multiplication of this regression coefficient with the x, that is your years of experience, 15. Okay, when it is done, then you have to add the constant. This constant means that when the value of x is 0, what will going to be the value of y, the predicted value of y when the x is 0. Okay, so you will going to put the value of x 0, and you will going to find out the value which you are going to put it over here. Then you will going to add the entire part, and you will be getting the value of y. That's how the linear regression works. That's how the linear regression works. Is it clear? Is this clear to everyone? Yes or no? Is this clear to everyone? Yes or no? Okay. So this is the theoretical concept of linear regression. Linear regression is very simple. The pros of linear regression is that it is very simple form of a regression. Okay, it is fast, and no basic knowledge or hyperparameter tuning has been involved over here. You can straight away you start using the linear regression. You don't need to study much about it. You should at least know how exactly is the working, what is the back end of linear regression. The reason being is that doing machine learning is a 5-minute job. Okay, so whenever you go on to an interview, whether it might be a data science interview, or it might be data analyst, or you can call it machine learning engineer or anything, they will always going to focus on understanding whether you know about the basics and the backend structure and the working, because they know that they will not going to tell you that, hey, I'm giving you a data and perform the linear regression, because they know that doing that is just a 5-minute task. You will going to take the help from some library, that is sklearn, and you can straight away do that, right? But what they will going to try to understand is whether you know about how exactly this function or this entire part works, how exactly this algorithm works, what is a backend story, right? If you are giving a data, what is happening in the backend, right? So this is how exactly what happened whenever you give a data, entire data to your model. Your model will going to try to calculate the coefficient regression from here. Then it will going to calculate the predicted value of y when your x is 0. We're going to put all the values in the equation y equals to mx plus c, and we're going to present you the data that I have predicted that when the value of x, that is the years of experience, is 15, the predicted salary will be so on and so forth. Okay, is this clear? Is this clear? Yes or no? Okay, perfect. Now similarly, we have a multiple regression as well. The only difference is over here, if you see, we have only one feature. That is your years of experience. When you have a multiple feature, for an example, this case, if you see, we have multiple feature, right? So BMI is not only dependent upon age, but it also depend upon height as well, right? So BMI dependent upon all the 3 features, and over here the number of features are more than one. Yes or no? So we cannot perform simple linear regression over here. Okay, we cannot perform a simple linear regression over here. We have to go with the multiple linear regression. Is this clear, everyone? Is this clear? Yes or no? Okay, awesome. So what exactly will going to change when you are dealing with your multiple linear regression, right? Everything will remain be the same, but only the thing is that you will going to add the number of features that you have. Okay, let's take for an example this data. Okay, so over here, let's take a very simple data. Let's take this data. Perfect. So let me copy this and let's paste this over here. Let's start. Okay, so this is the data. Okay, in this data, if you see, we have 4 columns, that is your sales person, sales intelligence, and then we have the extroversion, and then we have sales per week, so on and so forth, right? Over here, we are going to see that you need to predict the sales per week. You have to predict sales per week. It totally depends upon the intelligence of the person. it totally depends upon the extroversion of that person, right? And it totally depends upon the salesperson, who exactly is that salesperson, right? These are some other IDs, whether it might be no, associated with some kind of person, right? Over here you have multiple feature, and this sales per week is dependent upon multiple feature. It is dependent upon salesperson as well, depend upon intelligence, and depend upon extroversion, right? So earlier, for the simple linear regression, we were used to have the formula as y is equals to mx plus c, right? Mx plus c, right? Now what will going to happen, whenever you are dealing with a multiple linear regression, the formula will going to change to y is equals to m1 x1 plus m1 x2 plus m1 x3 plus, and it will going to go till m of n till x of n plus c. That is your constant. That is your constant, right? So the formula remain be the same, only the thing is that you need to find out the slope, the first slope that is associated with this feature, okay? You need to find out the slope that is associated with this feature with respect to your target variable, okay? Then you will going to get the x1 value, right? So the user will going to give you the input of x1, x2 and x3. Now the same way you will going to find out for all the three feature, and at last you will going to add this constant, okay? This how you will be getting all the entire value whenever you are dealing with your multiple linear regression. Is this clear? Is this clear? Yes or no? Is this clear to all of you? Yes or no? Okay. Now this is all about the theoretical concept of linear regression, right? Now some of the points that you should remember how exactly you have to start with, because these are the steps that you should know while dealing with machine learning, and these steps will remain be the same for all the machine learning algorithms, okay? First of all, what you need to do is, whenever you get a data, you have to get a data. First step will always be to get a data. Step 1, get a data, okay? This data can be of any source. It can be of .csv file, it can be of an Excel file, it can be you can call this as a SQL file, okay? Or you can download it from web itself, you can have a web scraping, okay, so on and so forth, okay? Now the step 2 is you need to perform data analysis. Now the thing is that why I am telling you to perform the data analysis, because data analysis itself contains 4 parts, that is data exploration, data manipulation, data cleaning and data visualization. This part is very important. This part is very important, that is data cleaning. If your data is not cleaned, then it will going to affect the model accuracy. If your data is not clean, then it will going to affect your model accuracy. And what does the cleaning means? That whenever you get a data, it is always called as a raw data. Raw data means a data that is not perfect, data that has a lot of miserable values, that is an unclean data, okay? You need to clean the data and make sure that data should be accurate, data should be perfect, because it will going to affect the accuracy. It is one among the factor that affects the accuracy as well. The good the good the data, the higher will be the accuracy. Always remember this thing. When you are done with your data analysis, now what you need to do is, now you need to divide your data into 2 parts. Now you need to divide your data into 2 parts. Till here is it clear? Till here is it clear? Yes or no? Till here is it clear? Yes or no? Okay. Now you need to divide your data into 2 parts. Okay. That means 2 parts will be your feature. So you will going to store all the feature on the X variable, and then you have a target variable, okay, which will be your Y. So earlier you were having a single data set, right? This is your single data set in which you are having the feature as well along with your target variable, right? Now what you're going to do is you will going to store the target variable into one variable, and you will going to store all the feature into one separate variable, that is your x and y. Okay, now when you are done with that, the next step will be to split the data set into two parts. Split the data set into two parts, and this is very very important. The two part is your training set and your testing set. Is it clear till here? Is this clear till here? Yes or no? Is this clear till here? Yes or no? Come on, give me a confirmation please. Okay, now why exactly we have to split the data set into two parts? Whenever I say splitting the data set into two parts, it means that if suppose this is your data, right, then what you're going to do is you are going to split the data into two half. That means this might be your first half. Let's say this is your first half and this is your second half, right? And this half is known as a training data set and this half is known as a testing data set. Why we do this? The reason being is that when we give the model that some data, right, when the model says that okay, I am trained with the data, I know that what exactly this variable means and what I have to predict, obviously you cannot believe the model, right? You have to test it, right? That means that for an example, when you go to school or college, right, the teacher will going to teach you some topic and after that you have an examination. That examination means examination will going to test out whether student knows about the concept or not, how exactly they are performing, right? So you should having the testing data as well. So that's why we divide the entire data set into two half, that is the training data set and the testing data set, right? So generally the ratio is ratio that goes in the market is 80 to 20. That means 80% should be dedicatedly will given to your training data set and 20% should be given to your testing data set, right? So now when you are done with your splitting the data set into two half, that is your training set and the testing set, now the next step is to initialize the model. Okay, initialize the model. That means in this case you will be going to use your linear regression model. Okay, when you have initialized your model, the next phase will be your training phase, where your model will going to get trained. Your model is going to understand the relationship. It will going to make a logic between the features and the target variable, so that whenever you are going to give them some new values, it can predict out the most accurate value. Okay, now the training phase. Now the training will going to start over here. Okay, when the training is done, now we have the testing phase. Right? And in this testing, how we exactly test the data, how we check whether the data is performing well and good, right? Now let's have the step 7 into certain parts. First, you will going to test the data to get the predicted values. You will going to give the testing data set to your model, and the model will going to give you a predicted values, and then you will going to compare those predicted values with your actual values. Compare predicted values with actual values. And what exactly is the predicted values and actual value? Let's see this. Let's suppose this is my data where it says that if the salesperson is 20, right, if the ID of the salesperson is 20, intelligence is 101 and the extroversion is 16, right, then the target value will be 2650. That's the actual value. It is the actual value, right? Now what will going to happen? Let's suppose my model is ready and my model is not been trained on this data. My model doesn't know what will be the outcome or suitable outcome for this kind of data. Now I am going to give the same input to the model. I am going to give the salesperson ID as 20 to this model. I am going to give this intelligence as 101 to this model, and I am going to give this extroversion as 16 to this model. Now the model will going to predict me this y variable, that is your sales per week, right? My model will going to predict something. Now the prediction that my model will going to predict, it is known as a predicted value. Okay, so it might happen my model might print 3000, it might print 3000 dollar sales per week, right? Now over here my actual value is 2650, but my model has predicted 3000. That means there is a difference, and when we say there is a difference, there is an error, there is an error, right? We calculate the error, and with the help of this error we specify the accuracy, right? So this is your actual value and this is your predicted value. Is this clear? Is this clear? Yes or no? Is this clear so far? Yes or no? Perfect. Now, after that, when you compare your predicted values and your actual values, you can easily find out the errors, okay? And you have to try your best that error should be minimized. Error should be minimized, right? More, the less the error, more will be the accuracy, or higher will be the accuracy, okay? Next step, that is your step 7b part, that is check the accuracy. This is very important. You need to check the accuracy of your model. How accurate is your model when introduced with a new data that the model has never experienced before? How exactly my model is a model is performing. So you need to check the accuracy, and for checking the accuracy we have different matrices. We have MSE matrices, we have R square matrices, and so on and so forth. You can use any of the matrices. Let me write it this over here. You can use mean square error, you can use mean absolute error, you can use R squared, and so on and so forth. So these are the steps that you need to follow in order to perform the entire machine learning phase. Is this clear to everyone? Yes or no? Is this clear to everyone? Yes or no? Come on. Okay, so this is the entire wrap of linear regression, how exactly linear regression works, what is the backend story of linear regression, and whenever you give some data or some features to linear regression model, how exactly it tries to predict this out. Okay, and now what are the steps in the machine learning phase, and these steps will be constant. Okay, these steps will be constants for either you are going to start with decision tree or random forest or classification models and so on and so forth. All the steps will remain be the same. Okay, so tomorrow when we are going to follow the practical implementation, we are going to take a random data set and we are going to try to follow these steps, and we are going to see how exactly we can easily use linear regression in the practical life, and we are going to try our best to achieve a higher accuracy so that our model will going to give us more higher prediction, and we can use it in further softwares. If you want to integrate in different mobile application, you can go ahead with that as well. Is this clear to everyone? Yes or no? Is this clear to everyone? Yes or no? Okay, perfect. And one request to everyone that tomorrow we have decided to take the session before 6 o'clock. Okay, so tomorrow we have decided to take the session before 6 o'clock. So I want to know what is the feasible timing for you guys to have this session, the last day session. Okay, so for tomorrow, instead of 7:30 to 8:30, we have decided to take the session before 6 o'clock. Okay, so that you can enjoy your time, you can enjoy your holidays and so on and so forth. So tell me the feasible timing that you guys are comfortable with. Come on, are you comfortable with 2 to 3 or 3 to 4, 4 to 5, or 5 to 6, any timing? Just tell me what is your feasible timing that you guys are comfortable with. Come on, tell me guys. Come on, come on, come on, come on. And simultaneously, if you have any question regarding the session, regarding the concept, you can ask right away on the chat section itself. Let's see. Okay. The thing is over here that there might be some default in the settings that my video has been reaching to you after like a 30 seconds or 1 minute, right? So that's the thing that we're going to try to resolve it. Apart from that, yeah, do let me know about the timings please, so that we can specify that and we can schedule the call at that particular time. So I hope that 5 to 6 is a best time for you guys, or you want to take it like during the afternoon, 2 to 3, or might be 3 to 4. Just let me know please. Come on guys, tell me the timing please. In the meantime, let me share the attendance link with you guys. Okay, so kindly please fill up the attendance link for the day 2, and let me ping this on the top of the chat section itself. 5 to 6, okay. 7 to 8 cannot be possible because we are trying to wrap up before 6, okay, so that you can enjoy your entire evening, you can enjoy your day after tomorrow, and so on and so forth, right? So I think 5 to 6, is it good to everyone? Yes or no? Can we go ahead with 5 to 6? Can we guys go ahead with 5 to 6? Yes or no? Perfect. Awesome. So let's do it from 5 to 6 tomorrow. Okay? Okay? Perfect. So let's make it to 5 to 6 tomorrow, and that's all for today. If you have any doubt, any question, please write it on the chat section.